Section 4.5b, Graphing Sine and Cosine Notes. The goal of the lesson is to graph sine and cosine functions with all of the transformations. In our previous class, we discussed how to find the amplitude, and we discussed how to use the b value to find the period. Remember that the period equals 2 pi over the absolute value of b. Today we will discuss bx minus c, which gives us the phase shift, and d, which gives the line of the middle. Practice number 1. We will now take our equation f of x equals 2 sine of 4x plus 3 and figure out the key components. 2 is our amplitude, so our amplitude equals 2. Plus 3, which is our d value, that represents our middle line. So our middle line is 3. Prior to this, our middle line was always 0, but now it's 3, which means the maximum value of our sine graph is going to be the middle line plus 2, which is our amplitude, which equals 5, and our minimum is the middle line, which is 3, minus 2, which is 1. So our sine graph is going to go from 1 to 5, with 3 being the middle line. Now we need to find the period. So period equals 2 pi over the absolute value of b. Now in this situation, b is 4. So our period equals 2 pi over 4, which reduces to pi over 2. Now once we have the period, we want to find the jump. Remember, the jump is the distance between each length in our sine or cosine graph. So we're going to take pi over 2 and we're going to multiply it by 1/4. So our jump for this graph is pi over 8. In the next slide, we will actually use all this information to graph. We just found the information, and now we're going to use that information to graph. Since our middle line is 3, we're going to go up 3, 1, 2, 3, and we're going to dot our middle line. Since the maximum is 5, we're going to dot the maximum. And we're also going to dot the minimum. Our sine graph is going to go between 1 and 5. The jump is going to determine our x scale. So our y scale in this situation is 1 because each tick mark is up 1. The jump is usually our x scale. So since our jump is pi over 8, that will be our x scale. So we're going to label it pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. You can simplify it, but it's not necessary. Now we're going to graph. Since this is a sine graph, we're going to start at our middle line, and our middle line is 3. So we start at 0, 3, then we go up to pi over 8, 5, and then back to the middle, and then down to the minimum, which is 1, back to the middle, up to the maximum, back to the middle, down to the minimum, back to the middle. And then we're going to draw our sine graph. Now, since it's a periodic function, it's really important that you put the arrows on. Our second example is our first example that actually has a phase shift. We'll deal with that at the very end. Our amplitude in this graph is 5, and our middle line is -1. That's our d value, which is our middle line. So our middle line is -1. Since our middle line is -1 and our amplitude is 5, we can find the maximum. The maximum is -1 plus 5, which is 4, and our minimum is our middle line, which is -1 minus 5, which is negative 6. So our maximum is 4 and our minimum is negative 6, with our middle line being negative 1. Now the period is related to the b value. So the b value in this situation is 2. So we know the period is 2 pi over the absolute value of b. So in this case, 2 pi over 2, which becomes pi. So our period is pi. Our jump is taking the period and dividing it by 4 or multiplying it by a fourth. So pi times 1/4 means our jump is pi over 4. Remember, pi over 4 is the distance between each part of the sine graph as it goes up, down to the middle. Now our shift is the last part we need to deal with. To find the shift, you take what's inside the parentheses and set it equal to 0. So my shift is 2x minus 2 pi equals 0. Now I'm going to solve for x. So I add 2 pi, and I have 2x equals 2 pi, and now I'm going to divide by 2. So x equals pi. That means my graph is shifted pi units to the right. We will use the information that we just found and graph our second practice problem. So since our middle line is negative 1, we're going to go down to negative 1 and dot the line at negative 1. Then we're going to go down to negative 6, so negative 2, negative 3, negative 4, negative 5. At this point, we realize there's a problem. We really can't make our y scale 1. We need to make our y scale 2 in order for the graph to work. So we're going to delete this and try again. So this is negative 2, negative 4, negative 6, 2, 4. So our middle line is at negative 1. Our maximum is at 4. We're going to dot the line at 4. And our minimum is at negative 6. Now, if the y scale had fit, we would have left it at 1, but we want to make sure it fits on the graph that's provided for us. Since our jump is pi over 4 and our starting point is pi, we don't need to make our x scale anything different. We can just make our x scale pi over 4. So I'm going to place the scale on my graph. So I have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Since we're doing a cosine graph, the cosine graph starts at the maximum. And remember, our starting point is in fact pi. So we're going to go to pi, which is right here, and we're going to go to the maximum. Our very first point is pi 4, because that's our maximum. Then it's a cosine graph, so then we're going to go down to the middle, and then down to the minimum, and then back to the middle, and up to the maximum. At this point, we realize we've run out of space. So we're going to return back to the maximum, and we're going to go backwards. So we're at the maximum, so we're going to go back to the middle, down to the minimum, back to the middle, up to the maximum, back to the middle, down to the minimum, back to the middle, up to the maximum. We want to always be sure to graph 2 full periods. So I'm going to draw this so I can make sure I've graphed 2 full periods. If I haven't graphed 2 full periods, I'm going to graph again. This is not a very good graph. Let me try it again. There we go. Remember, it's really important to have the arrows at the endpoints, and we've definitely graphed 2 full periods because you see there's a minimum, so that's 1 full period. And then from this minimum to this minimum is another full period. So we've successfully graphed 2 periods. If you recall what we just did in our last practice problem, the 2x minus 2 pi represented our shift. And the way we found our shift is we took 2x minus 2 pi and set it equal to 0, and we discovered that our graph was shifted pi units to the right. Well, another way to figure out the shift is to factor out something if it's obvious. So notice how there's a 2 there and a 2 here. So you can factor out the 2, and you're left with 5 cosine of 2, the quantity, x minus pi minus 1. Notice, if you remember from transformations, that this minus pi right here means since it's inside the parentheses, we're going to shift it right pi. So now there are 2 ways to find the phase shift. You can either set what's inside the parentheses equal to 0 and solve for x, or if you are able to factor something out, you can notice that what's left is just the shift. Remember, in order to factor something out, the x must be left by itself. Once again, there are 2 ways to find the phase shift. Either set what's inside the parentheses equal to 0 and solve for x, or if it's nice, pull out the b, and then the phase shift will just be that. If it's minus, it'll be to the right, and if it's positive, it'll be to the left. You can see in this example that the b value has already been factored out. So you can tell by the x plus 4 that our starting point, or our phase shift, will be 1/4 to the left. So we will be starting at x equals -1/4. Now, if you didn't notice that the 2 pi had been factored out, you could always just set x plus 1/4 equal to 0 and solve for x, in which case you would have also arrived at the fact that x equals -1/4, which is our starting point. Now, remember, the other key information that we need is we need to take the middle line. So the middle line is the d. So in this case, our d is -1. So our middle line is -1. And our maximum is determined by the middle line, in this case, -1, plus the amplitude. Now remember, the amplitude is the coefficient in front of the trig function, and we don't worry about this negative yet. We'll deal with that in a second. So the maximum, which is -1, plus the amplitude, which is 2/3, and the minimum is the middle line, which is -1, minus the amplitude, which is -2/3. So -1 plus 2/3 is +1/3. And -1 minus 2/3 is -1 2/3. We will use this information. I missed the negative sign up there. Okay, so we have the middle line, we have the maximum, we have the phase shift, the period. We need to find the period. So the period is 2 pi over b. In this case, our b is 2 pi. So it's going to be the period will be 2 pi over 2 pi, which is just 1. So our period is 1, which means our jump is our period, which is 1 times 1/4. So our jump is just 1/4. This is nice. Our jump is 1/4, and our phase shift is -1/4. So that will make our x scale fairly straightforward. We have our key information, and we can now put it on a graph. Since our d is -1, and our maximum is -1/3, and our minimum is -1 2/3, a reasonable x scale, y scale, would be a third. Let's see if we can fit that. So we have negative 1/3, negative 2/3, negative 1, negative 1 1/3, negative 1 2/3. Yes, that's the most reasonable. As we already pointed out, our jump is a fourth and our starting point is a fourth. So it makes the most sense to make our x scale 1/4. So we have 1/4, 1/2, 3/4, 1, 5/4, 6/4, 7/4. And then we have negative a fourth, negative 2/4, negative 3/4, negative 1, negative 5/4, negative 6/4. So now we need to factor in this negative sign. We have a negative sign graph. So when we start graphing sine, normally sine goes up. But because it's a negative sign, we're going to start at the middle and go down. We'll do that once we graph. So our middle line is negative 1. So at negative 1, we're going to dot our middle line. Then our maximum is at negative a third. And then our minimum is negative 1 2/3. So our starting point, as we said, is negative 1/4, and it's a sign graph, negative sign graph. So we're going to start at the middle. Now, because it's a negative sign graph, we're going to first start by going down. So negative 1/4, negative 1. Then we're going to go down to 0, negative 1 2/3. Then back to the middle, and then back to the maximum, back to the middle, down to the minimum, back to the middle, up to the maximum, back to the middle. So we have so far created our sign graph. Now we've graphed 2 periods, so we're done. But if you'd like to graph more, you can go backwards. Now remember, just in case you're wondering, because it's a negative sign graph, we started at the middle, but then we had to go down to the minimum first because it was a negative sign graph. Our last example takes into account everything that we've been doing from the beginning. So let's piece together everything and find our transformations. So our negative 3 is our d value. So d is negative 3, which is our middle line. Our amplitude, which is the coefficient in front of the trig, is 2. Now we do have a negative, but that just means it's a negative cosine graph, which we'll take into account when we actually graph it. So our maximum is negative 3 plus our amplitude, which is 2, which makes our maximum negative 1. And our minimum is our middle line, which is negative 3 minus the amplitude, which is negative 5. So our negative cosine graph is going to go between negative 5 and negative 1. Now our period is based on our b value. So our b value is the coefficient in front of the x. So as we know, period is 2 pi over b, absolute value of b, but this is positive. So we have 2 pi divided by pi over 2. So we have 2 pi over 1 divided by pi over 2. Remember, when we divide fractions, we change flip. So we keep the 2 pi, we change the division to multiplication, and we flip the 2 over pi to become 2 over pi. And our pi's cancel, so our period is 4. So our period, after all that work, is 4. Now our jump is found by taking the period, in this case 4, and multiplying it by a fourth. So when you multiply 4 times a fourth, you get 1. So our jump is going to be 1 unit. The last thing we need to do is the phase shift. We need to take the entire thing and set it equal to 0. This is not an easy one to factor, so I would just set it equal to 0. So we have pi over 2x plus pi over 4 equals 0. Remember, this is our phase shift. So we minus pi over 4. So we have pi over 2x equals negative pi over 4. Now we're going to isolate the x, so we're going to multiply by the reciprocal, 2 over pi, 2 over pi. When we simplify, we end up with negative 2 over 4, because our pi's are going to cancel, and negative 2 over 4 is negative 1/2. So our phase shift, is x equals negative 1/2. So we're going to shift 1/2 units to the left. We're going to take all the information that we just found and we're going to graph it on this graph below. The first thing we want to do is figure out our scales. Our minimum is -5 and our maximum is -1. It appears from our graph that we can go by ones. So our x scale, y scale. So our y scale can be 1. So let's graph our middle line. So we have a -3 as our middle line. And then our maximum is -1. And our minimum is -5. Now this is the first time where our x scale is a little bit trickier. Our graph is shifted left 1/2, so -1/2 is our starting point, and our jump is 1. We really would like the least common denominator between these two pieces of information. So instead of making our x scale the same as the jump, which is 1, we should really make our x scale 1/2. That way, when we do our phase shift, it's a little bit more straightforward. Now remember, if our x scale is 1/2 and our jump is 1, that means we're going to have to go over 2 boxes as opposed to 1. Normally we've been going over 1 box. So let's put in our scale. So we have 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So we have -0.5, -1, -1.5, -2, -2.5, -3, -3.5, -4, etc. So because -1/2 is our starting point and we have a negative cosine graph, negative cosine graph starts at the minimum. So we're going to go over to -1/2, which is right here, and we're going to go down to our minimum, which is -5. And that's where our graph's going to start. And because it's a negative cosine graph, we start at the minimum, then we go to the middle. Now because our jump is 1 and our scale is 1/2, we need to go to the middle, but we need to skip 2 boxes. So now we're at the middle, but we skip 2 boxes. Then we're going to go up to the max, skipping 2 boxes, and then back to the middle, and then down to the minimum, and then back to the middle. Now we're going to have to go backwards as well. So we have to go over 2. So back to the middle, to the maximum, to the middle, and then over to the minimum. So here is our negative cosine graph. Go back and do our arrows. Now once again, we know we have 2 periods because we go from the minimum to the minimum, and then once again from the minimum to the minimum. That's how we do that graph. The video is finished. Now you can start your homework.